So let's keep on going and start drawing graphs based on their pattern. Their pattern, of course, is like a template for cosine. Remember, cosine starts here, comes down, and goes over here like that, the cup, cosine cup, remember, in terms of its period. Now, what's its period? Well, obviously, it's not going to be 2 pi anymore. We might as well figure that out right away. We know that period then is, of course, 2 pi divided by b. So why don't we do this? Well, b is a fraction, so why don't we do this like we did in grade 7? 2 pi divided by 2 over 3 is the same as 2 pi times 3 over 2. And that makes it so much more convenient. And if you look, then we've got a period, of course, of 3 pi now. But here's the dilemma. The dilemma comes in right here. Look, your graph ain't big enough to show this entire portion of the graph because that graph is going to have its up and down movements all between 0 and 3 pi. Oh, lovely. So how do we do this? Well, I'm going to show you. Very simple. What you're going to do is you're going to only show a portion of it. Let's only show half of the graph. Let's show it from here down to here. That's what it's going to look like. So what's half of this? Well, multiply this by a half. You're going to get 1.5 pi. So you're going to show this graph over 1.5 pi. Well, let's do that. Okay, let's clean up a few things here. And let's see what this graph, half of this graph looks like. Okay, here's the other problem. We got an amplitude of 1/2 now. So let's put that in there and let's start creating our magic box. An amplitude of 1/2 is right there. 1/2 and a minus 1/2. So let's put in our magic box going this way and this way right now. Perfect. We know we're going to start at 0 here, and we know we're going to create the cup. The cup is going to be from here, and only a portion of the cup, half of the cup. Okay? So we're going to start up in this portion right up here, and we're going to end. But where do we end? Well, we're going to show only half of the cup, so 1.5 pi. So where is 1.5 pi? Well, there's pi. How many ticks is that? 1, 2, 3, 4, 5, 6 ticks to make pi. I wonder if that's 6 pi to make 6 ticks to make pi, what's 1.5? Isn't that just 3 ticks more? Right? Because half would be 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll show half of the graph. So half of the graph has got to be between these lines of the box. That's why we call it a magic box. Starting up here, of course, ending down here because that's what we've got from here down to this portion right here. Okay, perfect. But where's it going to cut? The cut is going to be halfway through. Okay, so count again. 1, 2, 3, 4, 5, 6, 7, 8, 9 ticks. Where's halfway through? Oh, 4.5. 1, 2, 3, 4.5. That's our tick right here. Okay, so halfway through. Okay, it's going to look an awful lot like that if you ask me. So why don't you keep on drawing this? Well, we can't because, of course, this is 3 pi, but we can continue on at least till 2 pi because if we count 1, 2, 3, 4.5, that will be the other portion, this portion right here of the graph, right? Okay, so let's just draw that other portion of the graph. Well, we get up to here and kind of put little dots here to kind of show us that we go to that other portion. Okay, so let's draw the left-hand side, the negative side. So again, we counted 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where the magic box is going to take us. Right to there, right? Perfect. Awesome. Excellent. So we're going to start way up here. We're going to end because remember, we're only showing half of it. So we're going to end right there. Don't forget at 4.5 ticks, 1, 2, 3, 4.5 ticks is where it's going to cut. 1, 2, 3, 4.5 ticks is where it's going to cut. So down it goes all the way to there. Count 1, 2, 3, 4.5 ticks. So it's going to come up and it's going to end up about here and then it's going to cut somewhere out that direction. Okay, so there's our graph. Beautiful. But I know what you're saying. Can we somehow prove this using our calculator? Well, of course we can. So we're going to take 1/2 cosine 2/3 x. We're going to throw it in our calculator. But watch the domains. We're going to set it up. Let's put that into our calculator right now. Boom. Notice one thing about your calculator. Unfortunately, right now, it's in degrees. You got to change it into radians because, of course, we're dealing everything with radians. Look at our original question. It's all in radians. And how can you tell? There you go. Okay. All right. So let's change it to radians. Okay. Mode. Radians. Enter. Second quit. Now it's saying up here that we're in radians. Good to go. Perfect. Now, let's throw in our nice little equation. Okay. Y equals 2. All right, y equals 2 right now is 1/2 cos 2/3 x. Okay, 1/2 cos, fraction again, 2/3 x. Beautiful. Look at that. There we go. Now, if we were to graph this, watch how crazy this graph is going to go. It's going to look really strange, isn't it? It doesn't look at all like our graph that we graphed here, does it? Well, the reason why is because look how our graph is set up. Set this up to look like our other graph. Go from -2 pi to 2 pi in our domain. Okay, so here we go. In our domain, window setting, that's our x setting. Go from -2 pi to 2 pi. That's perfect. Excellent. Let's go back to what we have here. Notice that we're going up 1, 2, 3, 4, 5, 6 to make a pi. So we're going up by a scale of pi over 6. So put it in. Second pi divided by 6. They're going up. That's the ticks going up a pi over 6. Okay. Now, how about our y? Our y went from 1, looks like, 1.5 to -1.5. That looks about right. So 1.5 to about -1.5. So -1.5 to +1.5. Now, if we punch it, we should get a graph that looks almost identical to what we graphed ourselves. So let's graph. Boom. Oh, there it is. And look at that. Compare the two. There's a calculator. There's what we drew. There's a calculator. There's what we drew. Oh, it looks almost identical. Look at that. It's beautiful. That's the best way in how to do graphs like this.